Today we're going to talk about complex numbers. And we're going to learn what the imaginary numbers are and what the complex numbers are. So we're going to start by thinking about some problems that we've done and solved many times. These three questions right here. Whoops. Whoa. Let me try this. Oh. There we go. These three questions right here. Misbehaving smartboard. There we go. So x squared minus 25 equals 0. One of the ways we could solve that is to add 25 to both sides and get x squared equals 25. And then square root both sides. And when we square root a number, remember plus and minus. And we would get x equals positive and negative 5. Two roots. They're unequal. Of course, they're real. And they're beautiful. That makes them rational. We could use the discriminant and figure that out as well. Where a is 1. B is actually 0 because there's no x term. And c is negative 25. So the discriminant comes out beautiful. But let's just solve these the same way. Add 32 to both sides. Now square root both sides. Plus and minus when you square root a number. And here we've got x equals positive and negative. And of course 32 is 16 times 2, which makes for a real nice 4 square root of 2. Now those roots, we have 2 of them. They are not equal. They're still real. And they are irrational. We can tell by that radical there. And last but not least, let's do this the same way. Subtract our 81 over this time. And we get x squared equals negative 81. Square root both sides. Plus and minus. And this time we have a negative under a radical, which might make you a little uncomfortable. Plus and minus. But I'm gonna separate this out. I know 81 is a perfect square, and the rest would be negative 1. So I'll put that in my other radical. So what I get is plus and minus. Square root of 81 is 9. And now what you're going to learn today is that the square root of negative 1 is going to be a small cursive I. So what we get here are 2 unequal roots, and these roots are imaginary. So this is new today. Let's take a look at what just happened. You know you can't take the square root of a negative number, but that rule is for the set of real numbers. If we expand our set of numbers, then we can get negatives under the radical. So here we have the symbol I is used in place of the square root of negative 1. And the set of numbers that include square root of negative 1 or I, they're called the pure imaginary numbers. I had two pure imaginary numbers right up there. The set of numbers that combines real numbers with pure imaginaries is called the set of complex numbers. So you've seen me writing when we did discriminant. We talked about complex conjugates. And that's where that is coming from. Okay, so we're going to evaluate most of these together. We've just got some negatives under our radicals, so let's see what we could do. We could split this up and say, oh, well, we know this is 16 times negative 1 under the radicals. Well, now you know this is 4, and the square root of negative 1 gets replaced with I. Matter of fact, let's write that over here. Square root of negative 1 is the same as I. Okay, there we go. Square root of negative 100. Another way to do this is to say as soon as you see a negative under a radical, bring out that I. So I'd prefer you do it that way. I square root of 100. Okay, now we know that's 10I. We're making this very simple. Pause if you'd like. Try a couple on your own. I'm going to keep doing them in order so you can check back. Negative under a radical, bring that I out. And I know I have radical 12, which I will show a little work for separated, is a radical 4 times a radical 3. So here I've got 2, I've got an I, and a square root of 3 stays in my problem. Here, this is negative 1 times whatever I got, so negative. I've got an I and a radical 50. So I've got negative 5, I, radical 2. Square root of 81, plain old 9. Square root of negative 81, 9I. Probably at this point, you don't need to break this up. But that's how I got 9I. Now I can't combine 9 plus 9I and write them as one term. We need to leave it as 9 plus 9I. And there's your first look at a complex number. You've got your real part, 9 is real, and your imaginary part, 9I. So a real plus or minus an imaginary is a complex number. Let's keep going. This means 2 times whatever I get. So 2 times, there's the negative under my radical. And I'll split up square root of 20 into 4 and 5. My smartboard is misbehaving here. This equals 2, so I end up with 4I radical 5. There we go, 4I radical 5. Square root of negative 27, I, and then the square root of 27. However, we're going to simplify that. Square root of negative 75, I, square root of 75. So let's work on those. This is 9 times 3. This is 25 times 3. So we'll get what will we get? 3I radical 3 plus 5I radical 3. Those I can combine because they have the exact same part. With a 5 plus a 3, it's 8I radical 3. Okay, let's see if I can just move that. Nothing's working on my smartboard. All right, let's see. Try again. There we go. Okay. Square root of negative 3 is I radical 3. Square root of 12, I could do a lot with that, but I know I can multiply under my radicals, so I have I radical 36, which is 6I. Now, there's a few other ways to get 6I. You might have simplified the square root of 12. As long as you get 6I, you've done it correctly. Square root of negative 16 is I radical 16. Square root of negative 4 is I square root of 4. So this one's interesting. We have 4I here times 2I here, which, pretend I is just a variable, is 8I squared. Now remember, I is the square root of -1. What if I squared I? Well, then I would be squaring the square root of -1. Well, you know when you square a square root, you get what's under the radical. So this means that I squared equals -1. That is true. So 8I squared is 8 times -1, or -8. We'll come back to that on the next page as well. A little division here at the bottom. We've got in the numerator 2 radical 3. In the denominator, let's see, it's 9 times 2, and an I comes out. 3I radical 2. Need to rationalize. Can't leave this radical 2 down there. So what are we going to get? Let's do the bottom first. 3 times 2 is 6. So we've got 6I. And on the top, 2 times 2 radical 6. Now we're not done. 2 and 6 can be reduced. So let me do this right down here. Radical 6 over 3I. Well, that's not working out very well. Radical 6 over 3I. Try it with this. Which actually simplifies further. I'll show you tomorrow that I isn't allowed to be in the denominator either. Don't know what's happening with my smartboard. Let me move that up and write that a little bit nicer. So what we'll do tomorrow, if you want to give it a try, we're going to rationalize the I as well. You can show me tomorrow what you think that would be. Last example, I know I have an I on the top, radical 15. And an I is pulled out on the bottom, radical 45. Now in this case, they will reduce each other out. I on the top and I on the bottom. And the radicals actually reduce each other out as well, because 15 goes into 15 once and into 45 3 times. So we've got 1 over the square root of 3. Rationalize. And we get the square root of 3 over 3. All right, let's do this last one. I radical 6 over 3I squared. And what does I squared equal? I squared is -1. So we get a -3 as part of our answer, or negative the whole thing. So we just did a lot of simplifying. Pure imaginaries are a single term. 3I, 2/5 I, 1.7 I, even -1.7 I. Complex numbers have a real part and a pure imaginary part. 2 plus 5I is a complex number. 6 plus I radical 3, there's your 2 parts, is a complex number. And let's do one more. 3 minus 7I is a complex number. So there's 3 examples for those. Well, a little bit of good news. Your graphing calculator can help you do some of these. So we're going to go find our mode button, and we're going to find A plus BI mode. It's all the way down at the bottom. So let's see if we can do that. Mode is right here. And if you go down to the bottom, not quite all the way. Here it is. It's in real mode right now. You can go over to A plus BI mode and hit enter. What that allows you to do, interestingly enough, is square roots of negative numbers. So if I put in the square root of negative 16, it will tell me for I. Let's see what happens for 2 plus square root of negative 64. Enter. 2 plus 8i. It even answers a complex number. Keep going. Square root of negative 100 plus square root of negative 16. Now predict ahead what this will be and hit enter when you're ready. The next thing to try on the calculator is I squared. So let's clear the key press history. And right above the decimal is a little I. So I want you to hit second decimal. There's an I. So if I want I squared, I can just hit the squared button and hit enter. Negative 1, but we already knew that. Let's try I to the third power. Uh-oh. Doesn't know what I was doing. Second decimal to the third. Much better. It's negative I. Interesting. Let's try I to the fourth. Second decimal to the fourth power. 1. Some interesting things came up there. I to the fourth is 1. I to the third is negative I. I squared was negative 1. Pretty sure you have the rest of these filled in. We don't really need our calculator to do these. They're pretty simple. But having it available to do some tougher problems might really be a benefit to you down the line. So this is a big deal. It's pretty easy too. So follow along with some thoughts that I have for you. Let's see if we can make this as simple as possible. If I draw a set of axes, and I'm going to label them, none of my pens are working, but I'm going to label them, over here a 1, and over here a negative 1. We're going to call this our real axis. And my y-axis, I'm going to relabel imaginary. And up in the positive imaginary section, I'm going to put a single I. And in the negative imaginary, I'm going to put in negative I. Let me polish that up a bit. Negative I. Oh, I don't know what my smartboard is doing. Okay. So we have 1, I, negative 1, negative I. These are going to be related to what we're going to do next. If I tried to do I to the 0 power, I to the 0, what would that give me? Anything to the 0 is 1. I to the first, well, that's just I squared we've already done. Negative 1. It's right up above. I cubed, we've already done. Negative I. I to the fourth is 1. So what we get here with this little I, negative 1, negative I, 1 is going to be a pattern. Because I to the fifth is simply, if you think about it, just I to the fourth times I That's 1i. I to the 6th is I to the 4th times I squared. I to the 4th is nice. We like I to the 4th. It's 1i squared, or negative 1. Try a couple of these on your calculator as well. What is I to the 7th? What is I to the 8th? It's 1. The pattern in each column is going to be identical. So I want you to think about it using this as a cycle of 4. If we start at I to the 0, we get 1. Traveling along, I to the 1st, traveling along, I squared, I cubed, just keep rotating. I to the 4th is 1. I to the 5th is I. And the 6th is negative 1. I to the 7th is negative I. I to the 8th is 1. So I to the 9th is I. I to the 10th, we're here now, is negative 1. I to the 11th is negative I. So let's finish this cycle. I to the 12th is 1. And I need you to come up with some conclusions here. The cycle is the same all the way through. I, negative 1, negative I, 1. I, negative 1, negative I, 1. I, negative 1, negative I, 1. We've only gone up to a power of 24. What happens if they ask us for I to the 33rd, or I to the 86th, or I to the 95th? Well, we don't want to go through this cycle 95 times, although we could. So there's a really nice way to take care of these larger powers. All right, we've noticed a cycle of 4. Do you notice anything special about the exponents in this bottom row where we just get 1? The exponents are 4, 8, 12, 16, 20, and 24. They're all multiples of 4. So we see if the exponent is a multiple of 4, then the result is 1. Very nice. So the method to handle these bigger exponents is to take the exponent divided by 4. If we have no remainder, we know that it equals 1. If we have a remainder, we rewrite it with that remainder. Let's try it. Number 1, our exponent is 24. So 24 divided by 4, 4 goes in 6 times, and there is no remainder. So this is the same as I to the 0, which equals 1. Let's keep going with this dividing by 4 method. 33 divided by 4. 4 goes in 8 times, and then you need 8 times 4 is 32 to get that remainder. This was 24 with no remainder. If the remainder is 1, then this is the same as I to the 1, or I. Let's try 86. 86 divided by 4. You can use your calculator to see how many times it goes in. we subtract then, and you see your remainder is 2. That means this equals I to the power of 2. I squared is negative 1. 95, pause and see if you can do it, divided by 4. Four goes into 95 23 times. That's 92 with a remainder of 3. So this is equal to I to the third, which equals negative I. Negative I. You will always get one of these in this first column. I, negative 1, negative I, or 1. Those are really good to practice. So there's a few tougher ones here at the bottom. 3i to the 27 just means 3 times what you get there. So let's take 27 and divide it by 4 and get our remainder. Remainder 3. So it's 3i to the third, which is negative 3i, because I to the third is negative I. Whoop. Negative 6 times what we get plus 4 times what we get. So we have to take that 18 and divide by 4. 4 goes into 4, or so, oops, I just gave the answer away. Goes in 4 times. Leaves us with a remainder of 2. So that's I squared. 64 divided by 4. 64 goes in 16 times. That is 64. There is no remainder. So this is I to the 0 remainder. So doing a little more work on those. Moving this down. Whoops. Whoops. There you go. Boy, oh boy. Didn't make it easy here. Okay. Negative 6 times negative 1 plus 4 times 1 is 6 plus 4, which equals 10. All right, last one on this page. We've got a 10, 11, 12, and 13. So we need 10 divided by 4. We're actually interested in the remainders, remember. 11 divided by 4. 12 divided by 4. Sometimes it's red, sometimes it's purple. And 13 divided by 4. 2 remainder 2. 2 remainder 3. This goes in 3 times. Remainder 0. This goes in 3 times, which is 12. Remainder 1. So I'm going to rewrite this entire line as I, only using the remainders now, squared, plus I to the third, plus I to the 0, plus I to the first. And what does that equal? I squared is negative I to the third. I'm sorry, let me redo that. I was 1 ahead of myself there. I misspoke. I squared is negative 1. I cubed is negative I to the 0 is 1. And I to the first is I. Negative 1 plus 1 is 0. Negative I plus I is 0. All that for 0. Okay, last part's real easy. Anytime we want to graph complex numbers, so anything like a plus bi, you simply draw a ray from the origin, which is 0, 0, to AB. And AB comes from the real part and the imaginary part. You have a real axis and imaginary axis, just like I did before. So if we want to graph 7 plus 2i, we're going to draw a ray to the point 7, 2. From the origin, 1, 2, 3, 4, 5, 6, 7, 1, 2, and a ray needs to stop right on the point. Negative 5, 8, draw a point to negative 5, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. A ray from the origin to that point. That's how you graph complex numbers. Have a great night. We will see you tomorrow. I'm just going to finish up. Negative 2, negative 5. Zip, there we go. Awesome. See you tomorrow.